Hi, this is Google Sheets. You can find Google Sheets at sheets.google.com. It used to be called Google Docs, so I think they still use that name. But sheets.google.com is easier to remember. Now, I have typed in my data here, just like a cooking show. I have done it in advance. And here I've got the volume, here I've got the mass. The mass is on the vertical axis and the volume is on the horizontal axis. You can see that I've got a line through here, and the line does not go through all the points. This is not a dot to dot. The line is the best fit line that approximates the pattern that all of these points seem to be following, if we can say that they're following a linear pattern. Now, there's a little equation here. This is 1.23 times x plus 1.16. That's the equation. Now, that equation corresponds to y equals mx plus b. So the y equals part is not shown here. So y equals m, 1.23, that's the m, that's the slope of the line. X plus b, 1.16, that's the y-intercept of this line, right? So this is the equation of the line. Now the r squared is an indication of how closely these dots fit the line. If the dots fit squarely on the line, then the r squared will be 1. If the dots fit almost on the line, then the r squared will be something around 0.9, as you see here. The software will calculate the r squared for you. It will also calculate the line equation for you, right? It is important to display the line equation and the r squared. The line equation, because that's the reason why we make a line, to get the equation, and the r squared to prove that the line equation is accurate for this data. Generally in science you want an r squared of something like 0.9. Sometimes 0.8 would be okay. In social science, such as psychology or sociology, when you graph some data from some survey or research, you want the r squared to be something like 0.66 or more, and that'll be fine. I want to show you all the steps that are required to get this graph and to get that line. So I'm going to delete this graph, and I'm going to make it again. So I highlight these two with the horizontal stuff in the first column and the vertical stuff in the second column. And then I go to Insert and I put Chart. Click on Chart. Now I have a chart. Looks like Google Sheets has already sensed that the vertical stuff is mass in grams and the horizontal stuff is volume in milliliters. That's cool. The title is kind of not that good because it is not very descriptive. It just names the vertical and the horizontal axes. So I'm going to add something to this title for the soap sample. So I took measurements of some soap samples. In the video lab, you will take measurements of some purple pieces of plastic. Actually, if you're watching the video lab, Dr. Paccarelli took measurements for you already of the purple pieces of plastic. All right, now I'm going to put the trend line in here. Whoops. Okay, I double-clicked on any part of this graph in order to see the chart editor. Right now, I'm going to click on one of these dots. So this is the data series. This is data series 1, and I'm going to select trend line. I selected linear. There are different kinds of trend line, but in science, the most useful trend line is the linear trend line because it gives you an equation, y equals mx plus b. And as you've seen in a previous assignment, the m is really important because that is the density. I'm going to click on Show r squared, and I'm going to click on Use Equation for the label. So now this is displaying the equation and is displaying the r squared. I see I have a title for the horizontal axis, a title for the vertical axis, and a title for the graph. The line is there, and that's all I need. Now, If the title doesn't show up automatically for the axes, horizontal and vertical axes, you can go here to the chart editor, customize, and look for the vertical axis title, and you can change that. You can put something in there. Or the horizontal axis title, you can change that. You can type something in there. Okay? All right, now, how are you going to get these volumes? Because the measurements that you, or Dr. Pecorelli, made in the lab were not volume. Remember, they were diameter, diameter, and they were length, and they were, that's it, just diameter and length for those purple pieces of plastic or whatever it is that you measured in the lab. So to get the volume, you're going to have to use the formula for the volume of a cylinder, because those pieces of plastic were cylinders. The volume of a cylinder is pi times the radius squared times the height, right? So pi, we can just call pi 3.14159, and the radius, that's going to be the diameter divided by 2. And the height, that's going to be the length. All right? Now it's important to remember about the significant figures here. For the radius, the diameter divided by 2, if the diameter was, let's say, okay, let's make a new space here. So for the radius, let's say that if the diameter were, let's say, 3.75 centimeters, and you want to divide that by 2, what is 3.75 divided by 2? If you just type an equal sign as the first thing you type in one of these boxes, you can do a little math problem, and the software will do the calculation for you. So the answer is 1.9, but that's not the answer that you would write down. The radius in this case would be 1.90 centimeters because of significant figures. We don't count significant figures in the 2 because that is not a measurement. We count the significant figures in the measurement only. Right? Now, what if the radius were 3.73, something like that? And then we wanted to get, what if the diameter were 3.73? The software was rounding the answer, which is not what I wanted. So I'm going to go to Format here and put number, and I'm going to have it not round. Okay, there we go. It's still rounding. So let me go to Format, put number here, and I'm going to have it do it like this. Yes, good. That's much better. Okay, so let's go back to the radius being 3.73 centimeters, right? I mean, the diameter being 3.73 centimeters, and the radius is 1.865. But see, that's not what you write down. The radius can only have 3 significant figures, so you have to round it yourself, you, the human being. So that is the radius, and you will do your calculation of the volume using that rounded radius, right? That's important because our instruments, in this case the ruler, doesn't have the capability of doing 4 significant figures. Doing to the thousandths place there. The ruler only has capability of going to the hundredths place because every tick mark is to the tenths place. So when you calculate your volume, you will use the rounded radius with the correct significant figures. Okay, now you are now ready to do this graph. There is a shortcut for doing the math that you could use if you want. You don't need to, but if you want, you don't have to necessarily do all the calculations by hand on a calculator. You can have Google Sheets do the calculations for you, and here's what I mean. So suppose you had the diameter typed in there, and you have the length typed in there, right? Or the height is what I mean by that, right? And I'm going to put volume here also, okay? So if the diameter was let me make something up, 3.73 centimeters. Notice I do not type centimeters, I just type the number. And the length, oh, this is rounding again. Oh, I have to make it not round, sorry. So I go to Format, I highlight the the boxes that I want to use. I go to Format, and I want to make it not round stuff. Well, actually, I do want it to round, but I want it to round it to the hundredths place because that's what the ruler is capable of, the hundredths place. So I'm going to use the number format that has, see, there's a hundredths place right there. I'm going to use that number format. Okay, so that's good. Well, that's the diameter, and the length is, I have the length of the small one. Let's say it was 5.255. The length of the medium one was 6.66. Let's say the length of the large one was 7.77. The length of the extra large one was 8.88. All right. And then I'm going to put a column for actually I'm going to put a column for the mass also right here. Okay. So what is the volume going to be? Now, because we're using software, if I type an equal sign here in this box, that tells the software that I'm going to ask it to do some math. So I'm going to say, software, please do 3.14159, which is pi, times the diameter divided by 2 squared. So I'm going to say 3.73 divided by 2, parenthesis, squared, right? This symbol is called a caret, and it is above the number 6 on my keyboard. So I typed Shift and 6. All right. So now that's pi r squared times the height. Now for the height, I'm going to take the mouse and I'm going to click on this right there. You see that? Now computer thinks it's B9. He thinks that because this is column B, row 9, right? I'm going to let him think that, and I'm going to press the Enter key. Right? Great. Now he's done the calculation for me. So notice in this is known as a formula. In this formula, everything is numbers except for the B9, this orange B9. The B9 is a variable, and you can let the computer change that variable like so. Let me show you. So I click on the box that has the formula. You see the formula shows up right there again. And you see there's a solid blue square at the lower right corner of that box. If I hover my mouse icon over that solid blue square, I get a skinny plus sign. You see that? A skinny plus sign. While I have the skinny plus sign, if I hold my left mouse button down, or if I hold my mouse button down and drag, I make dotted lines. Then if I release the mouse button, the software does it all by herself. See, she did the same formula. See, this formula is the same thing. Pi times radius squared, but this number, it used to be B9, now it's B10, meaning she's using that length. What about this one? Pi times radius squared, that B11. Now she's using that length. Pi times radius squared, B12. Now she's using that length. So see, she has done all the work for us, right? Now, what about the masses? Let's pretend I'm just going to make some numbers up for the masses. You got them from the lab or the lab video, but I'm just going to make some up just for this example. So let's say I had this mass for that, and then this mass for that, and then this mass for that, and then this mass for that, right? So if I have, the masses are already here. Oh, so sorry. We don't need the masses. So that's all I need to show you. So this video is over. So I just showed you how to have the software calculate the volume for you, so you don't have to do it on your calculator over and over again. That's totally optional. If you want to, you can do it on your calculator over and over again. And then at the beginning of the video, I showed you how to graph these things in the software, and then how to get the line and the equation of the line and the r squared. Now, before you turn this in, it's important to me and for your grade that you type somewhere in this file the following: density equals blah blah blah, y equals blah 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 mx plus b, r squared equals blah blah blah. Whatever you got, I want to see it right here. I want to know that you know how to interpret what the computer told you. And then I want you to make a statement like this: blah blah r squared, in my case 0.94, in your case it will be different, is close to 1, so our density data fits a line. Right? I want you to use those exact words, or some words that are like those words, right? Except I want you to use your own r squared, not mine. And that's it. Thank you very much.